Fog lights are an important safety feature on cars. Fog lamp lenses are subject to extreme mechanical and heat stress, which may weaken them and finally cause them to break. Holophane has perfected a new type of glass that withstands all of these stresses and eliminates the risk of breakage of fog lamp lenses. Hologlass 100, glass with a high level of resistance. Holophane specializes in automotive glass and has a worldwide reputation. It has developed an innovative process for the manufacture of a new type of glass, Hologlass 100. This process produces hardened lenses for fog lamps directly from the molten phase. Raw materials which are used to produce glass are vitrifiers, like silica, flux, such as sodium carbonate, stabilizers and refining substances that improve glass homogeneity. The vitrifiable mix is heated continuously in a furnace made of refractory materials to a temperature of 1500 degrees Celsius or 2730 degrees Fahrenheit. An electronic mechanism shapes the drop of glass, known as a parison, into a constant weight and shape. The calibrated parison is cut with mechanical shears and then drops into the mold in which it is pressed. When the fog lens is unmolded, an automatic oxygas flame treatment gives the glass its brilliant shine. As glass is an amorphous solid, hardening does not aim to modify its crystalline structure, but to put its various component layers under stress. The pressed lens goes into a heat stabilization tunnel, in which it is heated to approximately 650 degrees Celsius or 1200 degrees Fahrenheit, which is the optimal temperature for relieving it of stress. The part is then rapidly cooled by a controlled flow of cold air. First, the glass surface becomes rigid, and the molecules attain their final volume and dimension. Following this, the internal layers cool and try to contract, but they are blocked by the external layers, which results in tension caused by residual compression. This process gives the glass added resistance to mechanical or thermal shock. At the end of the process, all the fog lenses are checked for heat resistance and then washed. When the fog lamp is on, the lens is subject to a temperature of light projection of between 130 and 170 degrees Celsius, or 270 and 340 degrees Fahrenheit, which is considerably increased by external dirt. Standard lenses break when the extension stress is greater than the compression of the lens. Hologlass 100 glass is able to absorb the sudden variation in temperature without damaging the lens. Fog lamps are situated on the vehicle radiator grille, and its low positioning subjects the lens to the risk of shock, even at low speeds. When a shock occurs, the surface is deformed. The internal surface of the lens, which is in compression, is then subjected to traction forces. Standard lenses break when the traction force is greater than the compression of the lens. The distribution of the stress in Hologlass 100 glass enables it to absorb this deformation. Just as in mechanical shock, the surface of the lens is deformed. The internal surface of the lens, which is in compression, is subjected to a traction force that is too strong, causing the surface of a standard lens to rupture and then break. Holophane has perfected a control system that allows to guarantee the resistance of fog lenses in Hologlass 100 glass in genuine gravel conditions. The chipping test. A steel ball, 4mm in diameter, is projected by an airgun at a speed of 100 km an hour against a fog lens in Hologlass 100 glass placed flat on a specific medium. By absorbing the shock, the Hologlass 100 glass avoids the formation of a surface chip, which might trigger an internal split in the lens. 100% of the fog lenses in Hologlass 100 glass tested using this procedure withstand conditions of gravel projection at 100 km an hour. Hologlass 100 is 100% okay at 100 km an hour.